Good day, I am Christine Jarfrontila from BTLAHE2B, and we will talk about electronic components. Electronic components is any basic discrete device or physical entity in an electronic system used to affect electrons or their associated fields. So here are some examples are basic electronic components. Resistor. So what is a resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels to divided voltage, bias active elements, and terminate transition lines among other uses. And yung nasa baba ay a resistor symbol. So what does a resistor do? A resistor controls the flow of electrical current within a circuit. Resistors are made from material like copper or carbon, which make it difficult for the electrical charges to flow through a circuit. The most common type of resistor is a carbon resistor, which is a general purpose resistor, best suited for lower powered circuits. Some other common resistor types include the film resistor and the wire wound resistors. Resistors are essential to many electoral circuits, and they can be applied to a myriad of different applications. Resistors also protect components against voltage spikes. Components that are sensitive to high electrical current, like LED lights, will be damaged if there is not a resistor to control the flow of the electrical current. In addition, fuses as circuit breakers can also be used to protect your electrical circuits against voltage spikes. Resistors ensure components receive the proper voltage by creating a voltage drop. They can protect a component from voltage spikes. Each component is an electrical circuit, like a light or a switch requires a specific voltage. If a component in your circuit requires less voltage than the rest of your circuit, a resistor will create a voltage drop to ensure the component does not receive too much voltage. The resistor will create a voltage drop by slowing down or resisting the electrons as they try to flow through the resistor. If a component receives too much voltage, it may be damaged or not function properly. Next is capacitor. Capacitor is a device that stores electrical energy in an electrical field. It is a passive electronic component with two terminals. The effect of capacitor is known as capacitance. Here a symbol. And the importance of capacitor. A capacitor is also known as a condenser. Is one of the basic components required for building electronic circuits. The design of a circuit is not complete or it will not function properly without basic components, like resistors, inductors, diodes, transistor, and etc. The main function of capacitors is to store electrostatic energy and electrical field, and give this energy to the circuit when necessary. They allow the AC to pass but block the flow of DC to avoid hazardous breakdown of the circuit. Two capacitor, though capacitors are tiny, they provide various benefits in electronic circuits. They store energy directly onto the plates, which make the charging and discharging process much faster. They are effective in filtering out unwanted frequencies. Capacitors can handle power loss efficiently and make power production more economical. They are less sensitive to temperature. Capacitors discharge current almost instantaneously. Capacitors are prepared for AC application. They are capable of handling high voltage application and they and are therefore suitable for high frequency use cases. Capacitors have a long life cycle of almost 10 to 15 years. Next is inductor. Inductor is also called a coil, choke, or reactor. It's a passive two-thermal electrical component that stores energy in a magnetic field when electric current flows through it. An inductor typically consists of an insulated wire wound into a coil. Inductors are used in tuning circuits. With the help of inductors, the tuning circuit can select the desired frequency. The capacitors type along with the inductor are used in various electronic devices such as radio tuning circuits, a television or order to modify the frequency and help to the select within multiple channels of frequency. These are used as sensors. The inductive proximity sensors are very reliable in operation and and is a contactless sensor. Inductance is the main principle behind it in which the magnetic field in the coil will oppose the flow of electric current. The proximity sensor's mechanism is used the traffic lights to detect traffic density. It also used to store energy in a device. Inductors can store energy for a small period of time because the energy which is being stored as a magnetic field will be gone when the power supply is removed. Uses of inductor can be seen in computer circuits where power supply can be switched. Inductors are used for reducing current in AC circuit without any loss of electrical energy. When resistors are used, electrical energy is wasted in the form of heat. Next is transistor. A transistor is a semiconductor device used to amplify or switch electrical signals and power. The transistor is one of the basic building blocks of modern electronics. It is composed of semiconductor material, usually with at least three terminals for connection to an electronic circuit. A transistor consists of two p-n diodes connected back to back. It has three terminals, namely emitter, base, and collector. The basic idea behind the transistors is that it lets you control the flow of current through one channel by varying the intensity of a much smaller current that's flowing through a second channel. Terminals of transistor as discussed in the previous section, a transistor is composed of three terminals, emitter, collector, and base. And we discuss the functionalities of each terminal detail. The base serves as a gate controller device for a larger electric supply. The collector is a larger electrical supply. And the outlet of that supply is the emitter. The current flowing through the gate from a collector can be regulated by sending varying levels of current from the base. In this manner, a very small amount of current can be used to control a large amount of current like amplifiers. Transistors work as switch or as an amplifier. Emitter is this segment is on the left side of the transistor. It is moderately sized and heavily doped. Base. This segment is at the center of the transistors. It is thin and lightly doped. Collector. This is segment is on the right side of the transistor. It is larger than the emitter and it is moderately doped. Base emitter junction is forward bias. There are flow of electrons host from the emitter to base and host. Electron from the base to emitter. However, since the concentration of emitter electron hosts are greater than the base host, electron this current is primarily made of electron hosts. This emitter's electrons host become minority carries the base. However, since the base is narrow, very little electron hole, recombination occurs in the base and these electrons are drawn toward the collector base junction. Collector base junction is reverse biased when this emitter's electrons reach the collector base junction. They are pulled across the junction into the collector by the electric field due to the depletion region ions. Lastly is relay. Relay is an electrically operated switch. It is consists of a set of input terminals for a single or multiple control signals and a set of operating contact terminals. The switch may have any number of contact and multiple contact forms such as make contacts, break contacts, or combination thereof. Relays are useful as switching mechanism for pinball machines, telephone stations, automobiles, and more. Relay construction. Almost all the relays work on same principle, but there are different types of relays are available in the market. I am going to give you a basic example of simple glass relay here. Relay working. As you have seen the above image, uh, the main parts of relays are coil. The coil is the wire wound around the metal end. When the sufficient electrical power supply passes through this, it acts as a magnet. Moving armature. This is a moving part in the relay which opens and closes the contacts. An attached spring keeps the armature to its original position in a normal condition. Switch contacts. The relay is a switch. There must be contacts that are generally used to control another circuit. There are mainly two contacts, normally open and normally closed. Relay housing. The assembly of the armature with a magnetic coil is made with the help of spring. The spring is isolated from the armature by molded block, and the switch contacts are usually spot welded on the terminal link. Relay operation. A relay is an electromagnetic switch. A user can turn it on or off, depends on the logic. Relay has an electromagnetic coil. There are mainly two conditions like when power flows through these coils, it generates magnet field that attracts the armature and make the contact. When there is no power to electromagnetic coil, the armature rests its position and breaks the contact. We can see the relay as the normal state on the left side and the contacts are often in this state. While on the right side, relay is the energized state and contacts are closed also. Which indicates the relay is energized. So that's all. Thank you.